Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the GRI B190-12-W. This is a typical recessed door position switch that is used in steel doors and frames, and this is what it looks like. This is admittedly a little less common unit, and I don't know that I would recommend this as a standard unit because of the B in the part number. The B means biased. A B190 is what this is. Let's do a visual tour of the item. 3 wires, that tells us that it's going to be single pole, double throw, is what it'll be. You'll have a common, and you'll have the normally open leg, and you'll have the normally closed leg. Let's take some basic dimensional properties. This is a 3/4 diameter magnet, a little bit smaller than the 1 inch that you see more commonly. You can see the OD of the face is about 15/16. That's really going to be more that 3/4 inch, a reference to the body diameter. Length of the leads is likely about 12 inch. Indeed, about 12 inch. Ouch. This is probably the frame half, and here's the door half itself. Okay. The W in the part number means white. I think what we'll do now is let's talk about exactly where you're going to use this unit. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Now, admittedly, this is a little bit absolutely less common, at least in my experience. I don't see them biased for high security. So ultimately, this is a door position switch. What you're going to use it for is to in your access control, you're going to be able to control the flow of current based on whether or not the door is open or closed. That's the bottom line. We've got a white wire, we've got a green wire, and we've got a red wire. I don't know what is the common. I'm going to guess it's the white wire. It doesn't really matter as long as you have your voltmeter, because we can test for continuity. This is a very inexpensive voltmeter that does everything I need it to do. In fact, this was part of the class materials given in a DHI class. They're Core 133 maybe? I forget. It's basically the Intro to Electrified Hardware class. And I keep this here at work. It does everything I need it to do. And we can test for continuity with this, meaning that when we turn it on, and I have it set to continuity, which is that little audible that's there, okay, I can put a lead on what I think to be the common. And I can put a lead probe onto, or a lead onto, let's say, the red wire. And right now, I imagine you can hear that. I'm getting 0, and that's normal. I'll get 1 or overload when there is no continuity. Okay, infinity. So right now I know that when the magnet is not under influence, or when the door is open, this would be the door is open. When the door part is not near it. When I emulate the door being closed, the beeping goes away. That means now the circuit is open. What makes this unit unusual is that the margin between the two pieces is much tighter than otherwise. And that has everything to do with the way that they manufacture the material. If you're too close, or you're not in the sweet spot, you will trigger that magnet. So this will require tighter margins. Now, I will drop the red wire. I'll grab the green wire. In this instance, we should not hear any continuity because our door is open. It was giving us continuity with the red lead, and now indeed there is none. But when I have the door closed, now I get My fingers are probably getting jammed up here. Imagine you can hear that. So you can easily test for what is normally open and normally closed just by testing the wires. So, you know, this switch, this door position switch. So what I was trying to say there is you can take any single pole double throw switch. You don't really need to know what any of the wires do because you can test for continuity. Now to test that theory, I'll drop the white leg off and just put probes on the red and green, and I should get overload or not hear any continuity when the two pieces are present and when they're not. So I get no continuity. So my red and green, obviously one of them, neither of these is the common, is the bottom line. So that has to be the common because I only get action when I use the white with the red or the white with the green. I'm either getting continuity here or I'm getting continuity here. That's the bottom line. Super simple. So it's not super simple. It took me a long time to understand that. I find that going through the practice of physically taking the parts and wiring them is how to reinforce how this works. So this is a single pole double throw, meaning this one pole, and it's easier if you think of a knife switch. Just a knife switch. Just think of the movie Young Frankenstein where they throw the power. Actually, that's a single pole, single throw, I think. Well, imagine when you throw the power, you could throw it all the way down. What you throw, that's the pole. And you can either connect electricity this way or this way. Okay, depending on what action you are taking. Makes it a single pole double throw. Maybe that's an awful example, but that's the one that came to mind. So you're going to use this single pole double throw when you need to be able to have an action happen. You either need to have current flow when the door is closed, or you need to have current interrupted when the door is closed, or you need to have current flow when the door is open, or current interrupted when the door is open. By checking for continuity, you can determine, you'll know immediately which wires to use. It actually does tell us. It does tell us. This is a Form C. Form C is a single pole double throw. Common is white. Normally open is green. Normally closed is red. Common is white. Normally open is green, it said. So when I put my lead on the green, there's no continuity because this is not under influence. This is just how it comes out of the bag. Okay? That would be normally open. That means your circuit is open. The normally closed was the red lead. And you probably can hear that. So that's how you know if it's normally open. When it's not under influence, when you just take the parts out of the bag, you've not installed them. Normally open means there is no current flowing when it's just like this. It'll take this when it's normally open to close the circuit and cause current to flow. Normally closed is going to give you the opposite. No current, current. Okay? It's nice to see that legend because it'll tell you immediately, but it's nice to have a voltmeter. I found this online for $24. I mean, even if you never use a voltmeter, at the end of the day, you can always check continuity. And actually, in fact, it comes with a connection to be able to take the temperature of something, which is neat. If you ever go to a job site, if you ever get that call and your customer says, boy, this electric strike is really hot. Well, you could go there, install the temperature probe, and actually take a temperature of the unit and call the manufacturer and say, hey, I've got an operating temperature of 180 degrees. Is that normal? And that's how you would know. So back to the B190, you would use this when you have a need to have a tighter margin between the installation, meaning you can't tolerate a wide gap because normally in their standard material, I mean, you'll have like a 1-inch gap. So as long as you're within 1 inch, you'll affect a change. in that circuit, your application may not tolerate that. You might need to have tighter control over that margin. Okay. The way that they go about doing this is they basically alter the assembly of the internal parts. There is a document that we'll switch to, and we will take a closer look at the supporting documentation where we have paperwork from the manufacturer that it tells us how they do that, albeit it's a little bit confusing, but they do state how they do it. So let's do that. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Here's the item that we are looking at. A single pole double throw switch is called a Form C switch. If you were to look up Form A and Form B, you'll see what those look like graphically, but this is what's called a Form C. It'll have 3 leads. Other information is here as well. So let's take a look at some additional photographs. That's what you get when you buy one. Intended to snap into place. These different steps will allow you to accommodate different material thicknesses. 16 gauge, 14 gauge frame wouldn't be trouble. That's probably the door portion. Maybe it's not. Could be the door. Pardon me. That's probably the door portion, but maybe it's not. Maybe it's the frame portion. Depends on just what the rest of the electrical hardware would be. Your 3 leads. Now, let's take a look at the documentation that's here. And I won't read all of this to you. It's listed, posted down below. Biased for high security begins with a single pole double throw reed switch that is biased in an opposite condition. Basically what they do is they flip a part over that you have to be in the sweet spot of the two magnets coming into contact with each other at the right area in order to overcome the fact that they have flipped part of the assembly process over so as to require that sweet spot to be observed. Okay, so I'll leave this to you to read. If you have specific questions, ask about it, but the moral of the story is it tightens up the window of functionality to as tight as it can be, and that's done for applications where you can't tolerate a 3/4 or a 1-inch gap in something. You can get, in a standard door position switch, you can get that door quite open when you are permitting a 3/4 or 1-inch gap. This won't tolerate that nearly as much before you trip the door position switch. Now, there is a link below this video as seen here to the manufacturer's page, where you can pull up not only all of the GRI products that we sell by means of this horizontal navigation, but also a link to the GRI website, George Risk Industries. They make a variety of products that pertains to the door hardware industry as door position switches in different formats. And I'm very partial to GRI items, and it's because when you call them, they answer the phone and you ask for technical support, and that person answers the phone, and they're just great. They have replaced GE door position switches that are no longer available in terms of what we offer to clients, and I found it to be a perfect replacement, and they have a complete, comprehensive offering of material like this. Okay, check it out. Other things as well. Let's wrap up this video on camera. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, you know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up. Please subscribe and maybe even send the video to someone that you know. Thank you.